Hey, Dada, what are you doing?
Me? Oh, I'm doing magic.
No.
I'm not doing magic? Well, what do you think we're doing here?
I don't know.
Hey, why is it going over to you? Hey, what's that? Oh, it's coming to me. Oh. Well, hi. I'm Alex, Orion's dad. And this is Orion, Alex's son. And we're here to talk about electricity and magnetism. Orion, why would we talk about electricity and magnetism at the same time?
Because electricity and magnetism go together. Magnetism makes electricity, and electricity make magnetism.
They can do that, can't they? Sometimes we just see magnets like this. Do you want to show them what's actually happening? Show them what you're actually doing. Pull that
I'm
other one up.
actually dragging a magnet on the table, and it's getting sucked because these are two very powerful magnets, and it's getting dragged along.
Are you going to make it go crazy? Oh, you're kind of making it
Well,
go.
this is a little...
So, Orion, what's going on here? Well, yeah. So we're using a powerful magnet on the bottom of the table, and it's moving these magnets on the top of the table. These are kind of interesting magnets. They sort of like to roll around
And that was
crash
a funny
into
one.
each other.
This is a normal, what it would be like if...
That's kind of funny, huh?
Yeah, it makes the squeaky noise because it's so powerful that it goes together, but it's still vibrating.
Yeah.
And vibrations is what we hear as sound.
Mm-hmm. Magnetic force goes through the air and affects other magnets. You can see I'm moving one magnet and the other one is turning to point in the direction of the other one. There's something that we use in our daily life that's like that, that's pretty important. It's called a compass. If you look at the compass here, it's pointing in one direction. If I move the compass, the needle still points in that same direction. That's because the Earth has a very powerful magnetic field. The Earth is like a magnet, and the compass needle moves in that direction. It stays pointing towards the North Pole, which is where the magnetic field of the Earth comes out. And it goes all the way, wraps around the Earth, and goes to the South Pole. And that's kind of lucky for us because then we can use compasses to tell us what direction things are going in. Now, how could we move that compass, Orion? What would we want to use?
A magnet.
We'd use another magnet. So let's see what happens when you bring that over by it. Oh, man. Are you making the North Pole move, or are you just moving a magnet around the compass?
I'm just moving a magnet around a compass.
Yeah, pretty neat. So Orion, we just saw how magnets work together, and you kind of need two of them to have fun, right? One magnet alone doesn't do very much, but two magnets pull on each other in a very special way.
Or push on each other, like that one pulls this way, but there's a way that they push apart from each other too.
Now we're going to look at electricity. And here's an electric circuit. Here's some batteries and a light bulb and a switch. And all we have to do is wire them together, and then, the light bulb turns on. Oh, it didn't turn on. Why didn't it turn on?
Because electricity has to flow from here over to there. And
all the way around this
go
circuit,
like
right?
that.
Yeah.
If you do that, it will turn on.
Oh.
But if you do that, it won't. That's because electricity has to be touching other things that it can go through.
That's true. It needs metal or something like this so that it conducts. Metal wires, they have copper inside of them. They make it really easy for the electricity to flow from the batteries around, turn on the light by getting really hot in there, and then come back to the battery. And this little switch is open. There's no connection there, or it's closed. So Orion, how do we see electricity?
We see lights turning on, motors running, all sorts of things that electricity does.
That's true. Have we ever actually seen electrons?
No.
Okay.
They're too small.
I'll show you how we can see some electrons. Okay, let's see if we can make some right here that we can actually see. Ready? Here we go. Oh, hey, what's that? Ooh, I see some sparks and stuff. I think those are electrons. You know what that is actually? That is like lightning shooting through the sky. So Orion, this is a little spark maker right here. This is actually something you'd find in a lighter. And what I did is I just connected a wire to one end of it, and then I bring it over towards the other wire, and we can actually see sparks jumping across through the air. Those are electrons traveling from here to here, and they're actually burning through the air as they jump through, going almost the speed of light. Really quite interesting. But you know, there are other ways to see if electricity is flowing too. And what people who work with electricity usually do is not try to see it, they try to measure it. They try to figure out, you know, how much there is by using equipment like this. This is called an ammeter. An ammeter measures how much electricity is going through an electric circuit. So what I just did is add this ammeter right into our circuit here. I didn't do anything really that changed it, but let's turn that on and see if this moves that needle. Oh my goodness, it moved that needle. Okay, open it up again, try again. Oh wow, it moved the needle. It's telling us how much current is flowing through that circuit. It looks like there's quite a bit. Every time you open and close that switch, the current is flowing through this circuit, going through these wires and through the ammeter here and then back to the battery. So Orion, I've got another thing here. I hooked it up to the battery and to the switch, and it's just a coil of wire wrapped around this little screw, like maybe 100 times or so. What do you think it could do?
It could turn into a magnet.
It could turn into a magnet. Well, let's see. Let's send some electricity through it and see what happens. Ready?
Go.
Whoa, it pushed that thing away. How did that happen? Let's do that one more time. Let's move it over here. Nothing's happening. And then let's flip the switch. Hey, it pushed it away. That's kind of weird. So that means that the electrical current flowing through this little coil right here created a magnet. We call that an electromagnet, and it pushed away a regular magnet. That's pretty cool. So Orion, when you close that switch, electrical current, or electrons, are going to flow through these wires, through that light bulb, heat it up, make it glow, come over here, go through all these coils of wires. Those electrons are going to create a magnet by going through there, and then come back to the battery, and then come back around. Let's see what happens when you close that. Let's see if it really turns into a magnet. Ready? Whoa, you're making the compass move. Look at that. Whoa, by opening and closing that switch, you're really making that compass move. It is turning into a magnet. So now we've got the whole thing set up, everything we've learned about. Batteries connected to a switch, connected into a light bulb, over to an electromagnet, and then back through an ammeter that'll tell us if any current is flowing, and back to the battery. It's a big circle, which makes sense. It's a circuit, and the word circuit comes from the word circle. Okay, Orion, let's turn that thing on and see what happens. Oh man, the compass started moving, the light started lighting up, the ammeter is saying that we have current flowing, the whole thing is working. It's electricity and magnetism all at once. Pretty neat. So Orion, we just saw that electricity can create a magnet. Do you think a magnet can create electricity? Let's see if we can. You want to rub it on this and see what happens? Whoa. Now if you could film that, what's going on there? I see that there's some current, electrical current that we're measuring in this wire from you rubbing that magnet on there. Stop the magnet for a second. Oh, if you hold it close, it doesn't do anything, but if you move it again. Oh, if you move a magnet by a wire, you make electricity. That's an interesting thing, isn't it? Mm-hmm. That's pretty cool. You're making electricity by moving that magnet near those wires. So we just figured out that electricity can make a magnet, and that a magnet can make electricity. What if we put the two together? Here are some really powerful magnets. Can you check if those are powerful or not? Are they powerful? You can flip them over onto each other. Whoa, okay, what about that one? Okay, those are powerful magnets. So we're gonna take those powerful magnets and stick them to the bottom of a battery. Why would we wanna do that? Well, we'll find out.
I don't know.
Then we're gonna take this thing on top here and we're gonna put it on. It's just a wire that I've bent, and then see what happens as we spin it around. Okay. Bzz, bzz. Hey, it's really moving. Whoa. So, Orion, what was happening here? Well, I'll tell you. The battery was sending electrical current through this wire. This wire was sometimes touching the magnet, and then if it did that, it was making a whole circuit through so that electrons could flow through there. But when the electrons flow through the wire, they made a magnet, because electrons flowing through a wire, like we saw with the electromagnet, makes a magnet. And with the magnet down here at the bottom, they kind of work together to spin this thing around. Kind of interesting how that all works. That's how our motor works. We've seen how a light bulb works, basically by just getting hot when a lot of current goes through it. And we've seen how magnets and electricity work together. They interact. They make each other. Kind of interesting. Our world is full of electrons. Almost everything that we touch and feel is electrons. Whenever we say something or see something, usually it's the electrons that we're feeling or hearing. It's that part that gives us our sensations. Everything we touch is actually the electrons of the atoms that make up our world. And it's kind of interesting to see how they move and interact together. Thank you for spending a little bit of time with us today, Orion and his friends.
Do you want to introduce your friends?
This is Cammy, and this is Lobstery.
All right, well, that's it, Orion. Now we can just sit here and have fun with electricity and magnets, can't we? Whoa. Whoa, what's that doing? Whoa, whoa, my goodness. Whoa, Cammy, whoa.
Give me.
Huh? Whoa, oh my goodness. Whoa, look at that.